Hi everyone, welcome back to our YouTube channel Sid Education. In our today's video, we are gonna talk about another example on quick sort. So let's get started. Let's consider my array with the elements 6, 8, 7, 18 and 12 and I need to sort this array using quick sort. So what is the fundamental of quick sort? I'll just write it and then we are going to trace the algorithm. The fundamental of quicksort is that you need to select pivot, do partition, and recursive call. So for pivot element, what we do, we consider first element as my pivot element, right? Then what we do, we check pivot is greater than a of I. If this is true, increment, or I'll write this way. If this is true, increment I. Okay, if this is false, then you check the another condition called as pivot less than a of j. If this is true, you decrement j. If this is false, then you check whether I is less than j. If this is true, then what you check? You swap a of I with a of j. And if this is false, you swap pivot with a of j. Do not worry about what I have written this much. It is just to trace the algorithm I have written, right? To trace the algorithm. Okay. So just follow step by step process. You will be able to do this algorithm. Let's get started. So my example is 16, 8, 17, 18, 12. The step one is to select the pivot. Step one is pivot. My pivot element is 16. Second step is to initialize I. I is the left. So this is the leftmost. And again, you can call this as the rightmost, or you can, what you can do is you can insert one element from your side infinity and call this as the rightmost. So this is my J. Step one is to initialize pivot. Second, leftmost will be your I. Step three, initialize one more item infinity and initialize that as J. Are you getting it? Are you able to see what is pivot? The first element. What is I? The first element. What is J? Infinity, last item. Why we have used infinity in this example, not in our previous example? It is up to you. This taking infinity make your calculation easy sometimes, because many a times I have seen people struggling in the comparison, doing a comparison on quicksort. So to avoid that, I'm just saying this method. So if you like, or if you are okay with the first method or in example one method, I'm okay. If you think that this method will work for you, you can go ahead with this. So I'm going to solve some more examples using these kind of methods again. So you can practice in whatever method you are comfortable with. Okay. So with this also, I'm going to solve at least 2 to 3 questions so that you are having a quick hands-on on this. And with the example one, so I did not consider infinity in the example one. I just considered this as j because this remains same. It is just we are giving a limitation. That's only the difference I'm telling you. So don't get confused on this, right? So example one and example two are same. Only here I'm just defining a boundary. That boundary is infinity. Again, infinity is nothing, right? Alright. So let's get started. So if you remember, this is step 1 done, step 2 done, step 3 done. Now, what is the step 4? Step 4 is you quickly check pivot is greater than a of I. That is what this thing, right? So what is your pivot? 16. What is your a of I? Is 16 as of now, right? It is true. If this is true, what you need to do? Increment I. Remember, increment I. So your I will be this. 16 greater than 8. It is true. Increment I changes to this. 16 greater than equal to 7. This condition is true. Increment I. This I becomes here. Now 16 greater than equal to 80, this condition is false. So if this is false, what you need to do? You need to check the another condition. So check pivot is less than a of j. Change to this position, right? Whenever you get a false, you change. So 16 less than infinity. Infinity is big number, right? This is true. So decrement j. So j comes to this. Okay, j comes to this. Now is 16 then second. Is 16 less than 12? This condition is false. If it is false, what you do? So this is j and this is I. And I and j have not crossed each other. So what you do? You swap a of I with a of j. That is, if you consider 0, 1, 3, 4, and 5, I is 3 and j is 4. So I is less than j. So I is less than j. It's true. You swap a of I and a of j. So basically, you need to swap 12 and 18. So your question is, so your thing is 16, 8, 17, 12, 18, infinity. And where is your j? J is here. This is I and this is your pivot. Correct? Let's get started. So your pivot is 16. So what you do, you check pivot is greater than a of I, right? How you get started by this. Pivot is greater than a of I. So if 16 is greater than a of I is what? 12, which is true. Increment I. So your I changes to this. Correct? Is 16 greater than equal to 80? Is this true? No. How come 16 becomes greater? It's not true. 16 is less than. So if it is false, what we do? We check pivot is less than a of j. Correct? So 16 is less than a of j. A of j is 18. This condition is true. Decrement j. So j was this, j becomes this. Now is 16 less than 12? The condition is false. Now if you see, here is I, here is j. So I has crossed j. So what you need to do? You need to swap pivot with a of nothing but you need to swap 16 with 12. So your this becomes this 12, 8, 7, 16, 18. So this is your pivot. And if you see the elements left to it are less than this pivot element and elements right to this are greater than this pivot element. Correct? Now what you need to do? Again, you need to do whatever we have done. You need to apply quicksort again recursively on this, and you need to apply quicksort recursively on this. Right? We'll do it. Right? But fundamentally, you are understanding what you need to do. You need to get started with pivot greater than ag. If it is true, increment it. If it is false, check the pivot is less than a of j. If it is true, decrement. If it is false, stop and check which things to swap. And I told you how you will check which thing to swap. If I has crossed j, then you need to swap pivot with a of j. If I have not crossed j, then you swap I element and j element. I hope you are understanding this algorithm. If not, let's do that again, right? Because this is an element. So So I need to use this and use this. So I'm considering 12, 8, 17, 16. Again, you can consider this element, okay? There is nothing wrong because this is again act as a boundary. Because this is at right position, right? This is already at right position, so its position won't change. That's why infinity also, why I added infinity? Because infinity is right position. If you sort this array, infinity is at right position. So it acted as a boundary condition, correct? Okay, let's get started. So what is the step one? Step one is to select pivot. Pivot, initialize I, initialize j. Then what you do? Pivot greater than a of I. Pivot is 12, a of I is 12. This condition is true. Increment I. I becomes this. 12 Greater than 8, condition is true, increment I. Here I becomes this. 12 greater than 7, condition is true, increment I. So I becomes here. Now you need to stop because this acts as a boundary situation. You don't have more chances for I to grow, right? So you need to stop here. If you need to stop here, what you need to do is check for the J. So is pivot less than A of J? So if you see in this flow, right, you can mention if it is false or has reached to boundary condition, then also we do this, right? So boundary condition. So 12 less than 16. This was true. So decrement J. So J was this. So J will come here. Correct? Then 12 less than 7. Condition is false. Condition is false means we need to stop and we need to swap. Now we need to swap what? I has crossed J, right? I is less than J. Condition is false. So we need to swap pivot with J element. A of J element. So pivot is 12, A of J is 7. So your array becomes 7, 8, 12. This was your pivot. This was your last pivot, and 8 and infinity. This is your array. Now again, you have two elements left here and one element left here. I told you, if only one element is left here, you did not need to do. It is done. You need to stop there, quick sort, right? So if only one element is there, if there are two elements, you need to do that. So let's quickly trace it. So when you trace this, so 7, 8, 12, you need to sort. Step 1, pivot. Step 2, I. Step 3, J. Then step 4, pivot is greater than A of I. So pivot is 7, greater than equals to 7. Condition is true. Increment I. So I becomes this. Now 7 is greater than equal to 8. Condition is false. Stop. Stop in the sense what you need to do is you need to check pivot is less than A of J. So 7 is less than 12. Condition is true. Decrement J. So J is here. Now 7 is less than 8. Condition is true. Decrement J. J comes here. The 7 is less than 7. Condition is false. Means you need to stop. And when you need to stop, what you need to do? You need to swap. Now in this case, I has again crossed J. So you need to swap pivot with A of J. Now if you see pivot and A of J are same, 7 comma 7. So it remains 7. So 7, 8, 12. So this is at right position. 12 is at right position. Then 16 and 18, I think, if I'm not wrong. 7, 8, 12, 16, 18. Right? This is my sorry. So 18 we did not consider as any pivot element, right? The reason is it was sorted. So there was only one element. So now if you see there is only one element left to it. So you don't need to, you need to stop it here, right? So if you divide it right, there is no purpose. Subarray of one element, we do not apply a quicksort on that. So this is how my quicksort algorithm works. So if you still did not get the gist of the quicksort, we'll take few more examples. Example 3, example 4, example 5. Be with the videos, be with the example 3, be with the example 4. I'm definitely sure in example 5 you will be doing by your own. So if you like this video, please do like, share and subscribe. Thank you.